Hi, Professor Bob Young here, and in this instructional video, we're going to look at average rate of change along with some linear models. Now, the average rate of change, we know that the slope of a line is the ratio of the vertical change in y to the horizontal change in x, or the rise over the run. So the slope gives the rate of change in y per unit of change in x, where the value of y depends on the value of x. If f is a linear function defined on some interval a, b, then the average rate of change on that interval equals f of b minus f of a over b minus a. Now remember, f of b is a fancy name for what? The y value at that point b, and f of a is a fancy name for the y value of a. Why don't they just say that, Young? I know. Now for you business majors, interpreting slope as average rate of change, let's say in 2001, we've got a problem where the sales of DVD players numbered 12.7 million. In the year 2006, estimated sales of DVD players were 19.8 million. So we want to find the average rate of change in DVD players in millions per year. So if x equals 2001 with y equal to 12.7 and x equals 2006 with y equal to 19.8, the ordered pairs we get are as follows. So I'm going to go ahead with my marker here and label these things. So let's call the year 2001 A, and that number 12.7, the y value there, f of a. And in 2006, we'll call that B, and I bet you know what we're going to call the other one. F of B. So there's some new ways to write some ordered pairs. All right, so let's go ahead and rewrite this one more time here. We'll go ahead and say A, F of A, B, F of B. And using this formula, it's almost like the slope formula, the change in y over the change in x. So notice we're just taking y2 in this case, which might be considered f of b, minus y1, which might be considered f of a, over, guess what, b minus a here. So x2 minus x1 if you look at it that way. And notice when we do the arithmetic, we come out with 1.42. So the line through the ordered pairs rises from left to right, and it has a positive slope. And the sales of DVD players increase by an average of 1.42 million from the years 2001 to 2006. So you can actually use this stuff in real life. Wow, that's just scary, Young. Now, some linear models. And if the linear cost function has this form, c of x, which of course c now is the name of the function cost, equals mx plus b, where x represents the number of items produced, m represents the variable cost per item, and b represents the fixed cost. The fixed costs do not change as more items are made. This is how the business world works. The variable cost per item increases as more product is made. Now, the revenue function for selling depends on the price per item P and the number of items sold X. So here we go. The linear cost function has this form we've already mentioned. C of X equals MX plus B. The revenue function has the form R of X equals PX. And the profit described by the profit function is defined as P of X equals R of X minus C of X. So let's take some examples here. I know I'm going through all this function stuff, and y'all are probably scratching your head. They're like, huh? So we'll do some examples. So assume that the cost to produce an item is a linear function, and all items produced are sold. The fixed cost is $1,500. The variable cost per item is $100, and the item sells for $125. Write the linear functions to model. So for part A, we'll say the cost, C of X, equals MX plus B, and we know that per item it's going to be $100 here, the M part, okay? And the fixed cost B starts out at $1,500. All right, now part B, the revenue here. All right, now each item sells for a unit price of $125 here. So we're just going to take for P and plug that part in here to get the revenue. And then to get the profit, we can use the formula P of X equals R of X minus C of X. So in order to get the profit here, we're going to take the R of X here, and you got to be real careful, folks. And when you subtract the cost, which is 100x plus 1,500, as we described, where students miss this is they forget to distribute that minus sign through, which changes these signs down here, so be careful. So the profit in terms of X would be 25x minus 1,500. All right, now it says part D here, how many items must be sold for the company to make a profit? To make a profit, P of X must be positive. So we just found earlier that the profit P of X is 25x minus 1,500. So in order for the profit to be greater than 0, we're just going to take that P of X here, which we found was 25x minus 1,500, set it equal to 0, and solve. So we'll add 1,500 to both sides of the inequality. And we're going to get to, well, we've done the inequalities earlier, divide both sides by 25. And notice it says X is greater than 60. Now, since the number of items must be a whole number, you've got to sell at least 61 items in order to make a profit. So I guess around 60, you're going to break even. So for business majors and even others in different situations, you can use a lot of the functional items in real life. So Bob Young signing off. We'll see you in the next